So the next session, the first of three, will be about sharing some insights in EU-funded projects which all are addressing teleoperation. We have three different projects here today to talk about their work: 5G-Blueprint, 5G-Croco, and 5G-Mobix. And we have the three panelists that will present them. Let me briefly introduce them to you. So for 5G-Blueprint, the speaker is Johan Marques Barja. Johan is a professor at the University of Antwerp, as well as a professor in IMEC Belgium. He is leading the wireless cluster at IMEC Antwerp and ID Lab. He was and is involved in several European research projects. He's a member of ACM and a senior member of the IEEE Communication Society, IEEE Vehicular Technology Society, and IEEE Education Society, where he participates in the boards of the standards committees. His main research interests are 5G advanced architectures, including edge computing, flexible and programmable future end-to-end networks, IoT communications, and applications. He's also interested in vehicular communications, mobility, and smart cities deployments. So, Johan, if you'd like, the floor is yours now to briefly introduce 5G-Blueprint.
Thank you. As usual, I should ask, do you see me? Do you hear me?
We can hear and see you, yes.
Okay, now I will share my screen and I will continue asking, do you, and now the usual question, which screen do you see? Full or the presenter?
The presenter's view with the,
now
this is better, yeah.
Oh, thank you. Yeah. After the usual questions nowadays in online Corona times, first of all, I want to thanks to the organizing committee for organizing such an interesting teleoperation forum with different perspectives. That's going to be useful to all of us. It's going to be a rich afternoon where we are going to learn from each other. Now let me talk about 5G-Blueprint. 5G-Blueprint, it's a Horizon 2020 project that focuses on designing and later validating a 5G architecture that's capable to take teleoperation into, oops, sorry, the animations. That 5G that's capable to take teleoperation, to make it into a reality, an analysis, a design, a blueprint of how 5G should be designed in order to cope with the hard requirements of teleoperation. Moreover, it's not only about the technical analysis and the technical architecture, 5G, a technical architecture that we are going to design at the end of the project. It's about also understanding the business models behind teleoperation that are going to make teleoperation a reality. What's going to be the most attractive incentives in the business, in the ecosystem in order to make teleoperation a reality. So business models are important, and we are also looking into it. And last but not least, regulation and governance models. What should be, what frameworks, what legal frameworks or regulation frameworks should be enhanced or put it into place in order to have the perfect recipe, the perfect blueprint to have regulation, business models, and technical solutions to really put teleoperation into place in the domain of transport and logistics, aiming the vertical of transport and logistics. So there's a strong 5G focus here, the strong teleoperation, of course, the vertical teleoperation focus. And for this teleoperation focus, we have to look also into the business and the regulation that are going to be a key player. So what do we aim? We aim to teleoperate trucks and vessels, to telesail vessels and to teledrive trucks that are at the core of transport and logistics. So we want to be able to enable remote driving, remote sailing from a central control center, and to be able to deliver goods from end to end, from door to door, to deliver goods remotely. Therefore, we need to be able to manage these goods remotely, to transport them on the highways remotely, to get into the port or to the houseware and remotely, to be able to manage this load and to ship it remotely and to telesale remotely these goods. So there's a whole chain. Technology-wise, in the whole chain, we need to understand how 5G it's a key enabler. And apart from that, what extra functionality we should have it to make this a possibility. Then we have also the economic side, the business model. What does that, all this technology, what does that mean in the economic side, in the business model behind? We understand the incentive and the goals where we start thinking about this project, this proposal, and then project, thanks to the funding of the European Commission. It was about what affects to the vertical and teleoperation. And most of our findings, thanks to our partners, many industrial partners that are at the core of the at the core of the transport and logistics, we identify main things, and we will continue identifying, and we are already discussing these things: how to reduce the waiting times, how to reduce the big problem of labor shortage we have seen lately. This is not a supposedly event that will come someday. It already came. There's a lack of drivers. There's a lack of labor in the transport and logistics sector. How can we help with teleoperation, with technology? Of course, economical growth, safer driving, better conditions for a tele-driver, tele-sailor to do it remotely from a comfortable place and going home at the end of the day. So all these economical matters that are affected by the technology. Regarding the technology, we need to be able to deliver a 5G network that supports all of this pressure, I will say pressure, these hard requirements, this pressure from the verticals. And we need to be, of course, low latency, because we're talking about safety and how to drive remotely trucks, devices that they go 80 kilometers per hour. Has to be reliable, secure, guaranteed, and cross-border. This is an important aspect for all European projects that are in this area. The beauty of the free mobility that we have in Europe needs to be enhanced by the beauty of technology that supports cross-border connectivity, seamless cross-border connectivity that allows this technology to freely move in Europe and crossing the borders in the different frontiers of our countries here in Europe. And finally, what's the law? What's the regulation? What the regulation should look into it regarding teleoperation, and also regarding factors between the companies that are part of this sector, this vertical, such as also understanding how the operators in this, for example, in this cross-border scenario, what will be the regulation? How can we ease the way that they can work together, not only from the technical perspective on doing a handover, but also from the regulation? What will be the service level agreement? How can we work together at the crossing the border line? As I mentioned, we have 3 different areas where we are active: the technological, the business, and the regulatory. As I already said, from the technological point of view, we must design a 5G, to recommend, design, test, and then to have a set of recommendations, blueprints, that's the name of our project, a set of recommendations on what should be enhanced in the 5G architecture in order to support this connected and automated mobility services. So this is the recipe to have a safe, secure, cross-border, etc., 5G technology, and that's what we are looking into it. Apart from the connectivity perspective, there are many other things that need to be enhanced in the teleoperation area, in the different processes and the different technologies that need to be also researched and developed and enhanced to make teleoperation a reality. It's not only about providing such a nice 5G connectivity, which is important for us, but also we need add-ons from the vertical, from the teleoperation. What else do we need to develop in the teleoperation ecosystem to make this a reality? And we need to validate and to give this as a blueprint, as an advice for companies that they want to apply this and they want to make teleoperation a reality. It's not only a technical advice, it's also business model advice and also a recommendation advice. From the business model, we are looking into what is the business behind for the different actors. What is the biggest incentive for them to move and to work with teleoperation? And from the regulation, as I mentioned just in the slide before, we need to be able to understand what the regulation, the law, the standardization should say about this in order to ease the path to the future. How are we going to do this? As you can see in this slide, in the center of the project, it's 5G connectivity and teleoperation. These two worlds need to be together. These two worlds have importance. These are two technical words that they come together in order to make the use cases a reality, and the use cases will reflect and will demonstrate what we are achieving and aiming. Well, aiming and achieving. We will we have 4 use cases. As I mentioned before, it's door to door, so we want to transport goods, and there are different phases in this transportation of the goods, and those different phases we want to be able to teleoperate them. One use case is that we want to teleoperate, telesail the vessels, the cargo vessels, and we want them to in 2 different ports, in Vlissingen and Antwerp. Sorry, the animations. We want them to we want to be able to teleoperate and to take in and out of the port these vessels. Also, we want to be able to drive. Let's say here, we want to be able to teledrive the vehicles. With a click of a button, we want to be able to switch a teledriver to switch from one truck to another, because this truck is stopped and is waiting, it's queuing to be in the port, let's say, to be loaded or unloaded. There's no need for those waiting times. And then we can, with a button, click and to remote take over a different track. So we want to enable that technology. For example, when the truck it's getting into the port, we want to be able to teleoperate and also to have up to some extent some automated systems to support that the truck needs to be parked, needs to be loaded. We want to operate a crane and to load and unload remotely. And then we also look into platooning. Many other projects have already looked into platooning. They are now looking into platooning. And we do as well, but from a different perspective. We want to optimize a platooning in order to transport the goods. So teleoperate the head of the platooning and the other trucks platooning to the head. As I mentioned before, it's not only about 5G connectivity, but it's also about the extra functionality that the teleoperation sector requires. We are exploring. We call them enabling functions. We should call them enabling enhanced functions, to be honest, because we enhance the teleoperation. We are exploring different other plugins in order to make this a reality. So basically, we are developing a powerful teleoperation center. And from there, with different other enabling functions, we are going to be able to take care of vulnerable road users. So our trucks and vessels, they need to be aware of the context in order to avoid any accident. Safety first. We need to be able to control or to operate as well traffic lights in order to make sure that there's a smooth path for a platooning. We need to have that functionality as well connected with 5G, but that functionality it's on the ITS services. We apply AI to understand from several sources to understand distributed perception. There are many other functions. that we are looking into it. And please visit our website to see all those details. This is a big, broad overview that I am providing to you. How can we make this? With the expertise of many sectors. As you can see in this slide, we are a lucky consortium to have very important partners from their sectors. In order to put this whole shebang together, we need to have, of course, network operators. We need to have OEMs, vehicle and tracks providers. We are also working with DAF as part of the track providing tracks. Toyota is providing vehicles. We have expert on teleoperations, Vitron, RoboAuto, CFAR on the vessels. We need to understand the transport and logistics. So we have different expert companies that they know how the process goes, and they make sure that the technology that we are designing is really useful for them in their sector, in the transport, at the ports, and software that's related to this. Of course, connected mobility, we have experts there. Research behind, we have different research institutes. I represent IMEC, we are the technical coordinators. We have business accelerators in order to understand the business models and to interact with the companies. And last but not least, government. As I mentioned, this is aligned to the projects, to the goals, sorry. Technology, business models, and regulation. So we have all the right expertise in order to address these goals. And in the government, we have at both sides of the border. We have the Netherlands and Belgium, and two governments are part of the consortium. And as a matter of fact, the Ministry of Industry and Water Management from the Netherlands, it's coordinating this project. So thank you very much for your time. There are so many interesting things to see, so many interesting technical results, business analysis that we have so far. We are running, we are a 36 months project, and we are we have just reached our first year, and our first results are available in our website. Please visit us, and well, here happy to share with you this afternoon. I give the floor back to our next speaker. Thank you.
Thank you, Johan, for your inspiring talk about the 5G blueprint and how it's really trying to go in depth, I can say, I think, on all concepts related to teleoperation and 5G technology supporting it. Okay, so this was one project out of three. Our next speaker is Tobias Müller. I forgot to share my screen. So he will be presenting the 5G Croco project. Tobias, in 2013, after his studies in computer science and psychology at the University of Paderborn, Germany, and the University of Nanjing, China, Tobias joined Bosch Corporate Research. He's a research engineer for augmented reality, and in the following years, he held various positions at Bosch in the development of head-up displays and cluster instruments, as well as in advanced development for automated driving. Since 2020, he is the project manager in pre-development for connected automated driving, where he leads Bosch internal as well as publicly funded projects. The focus of his work is on creating driving functions that exploit data sources from outside a vehicle. So I'm very happy and honored, Tobias, to have you here today. So if you'd like, let's give you the opportunity now to talk us a bit through what 5G Croco is doing in the context of teleoperation.
Thank you very much, Wim. Let me just share my screen. Give me a second, and then I can start with my talk. So you should now be able to see my presentation.
Yes, we can. Yeah.
Okay, great. Then let me start. First of all, thank you very much for the opportunity for being here and presenting 5G Croco and the results we have achieved so far. So other than the previous talk, I actually will focus more on the technical aspects or on the conceptual aspects of how we imagine teleoperated driving to be in 5G Croco. But before we start there we are. Let me give you a short overview of 5G Croco. 5G Croco is focused on 5th generation cross-border control, which means 5G networks for automotive applications in the international in the European border areas. We are overall 24 partners from 7 countries, and we originally were supposed to be a 36 months project. However, due to COVID and due to the problem that we couldn't complete all the work in time, we recently extended to 44 months. And so we are now 3 years into the project, and we have roughly half a year left. And just before I go to the next slide, because we are talking about teleoperated driving, on this map I gave you here the circles where actually we do our teleoperated parts of the project. One is in Munich at the Huawei campus, and this is especially relevant here for this talk. The other red circle, which is the German-French and German-Luxembourgish border area, where we trial most of our technologies. However, let me short give you an introduction on the 3 use cases that we consider in 5G Croco. First of all, teleoperated driving. This is what I'll be talking about today, and where I'll give you an introduction to on what we did there and how we see teleoperated driving in the project. However, we also have 2 other use cases. One is HD maps, which is basically the use of 5G networks for HD maps in the European border areas. And we have ACA, the Anticipated Cooperative Collision Avoidance, which is about using 5G to avoid collisions, especially at the end of traffic jams, or if there's a car somewhere on a road with a lot of sharp turns where you can hardly really see what is coming up behind the turn. However, we are here for teleoperated driving, so let me just jump right into the topic here. And one thing that I want to give you as a core message here today is that we learned that teleoperated driving is not on-off, like there is no teleoperated driving all the way where only human operator controls everything. Teleoperated driving is always located somewhere on a spectrum between that the vehicle is in full control and that the human operator is in full control. And it's somewhere in between. So, I mean, a lot of participants here probably have seen the concept where you have a vehicle driving somewhere, and then you have an operator with a steering wheel and with pedals for gas and brake. And then this person controls the vehicle, and the vehicle drives as if this person were sitting in the vehicle. However, this is just one extreme case of teleoperated driving. And instead, you could also think of a very simple case where a vehicle, an automated vehicle, wants to start, and the operator only gives the okay for the start, and that's the whole teleoperation aspect. However, an operator might also support situation analysis. So, for example, a vehicle doesn't know what's in front of it and asks the operator on support. And the operator can say, for example, yeah, that's not a big thing. It's only some dirt on the road. You can go ahead. Or that the operator approves specific maneuvers like driving over the sidewalk. And this is something that when you look into teleoperation, and when you also think about really doing teleoperated driving in a larger area, and especially in border areas, you have to consider the question, okay, how much human do I actually want to have in teleoperation? How much automated vehicle do I want to have in teleoperation? However, this obviously also means that you have to have some sort of automation if you do not want to leave the human operator in full control. So for us here at Bosch and also in 5G Croco, teleoperation always is a combination that goes together with automated vehicles. And you do not only have like dumb vehicles which do not know anything, but instead you really have to have some sort of automation and some sort of sensing and actuation automation in the vehicle. So let me get to what we actually do in 5G Croco. Well, we especially on the TOD part were considering 2 concepts for teleoperated driving. One, which we call direct control. This is really the example where you have an operator who takes over the vehicle with the steering wheel and pedals and drives the vehicle. And this is for us a case that we especially use to research on how 5G networks and teleoperation work together. Because if you do direct control, you need to have lots of features from 5G. So for example, you need to have the low latency. If the latency gets larger, the operator sees something from the vehicle, like for example, the vehicle has a camera mounted, and then this camera image is transferred to the operator. Then the operator reacts with the steering wheel or with the brake or whatever, and the signal is sent back. And if there you have a really high latency, this will simply not work because, well, the operator sees something's too late or the control signals arrive at the vehicles too late. The other thing also is the high bandwidth with 5G, because so for example, at Bosch in our vehicle, we installed 7 cameras to give the operator a really good surround view to the front, to the sides, and to the back, and transmitting 7 video streams in a high quality, which is comparable to full HD, a little bit more, a little bit less, depending on the configuration. There, you also really need to have the high bandwidth. So this use case for us was something where we really wanted to use to try out what can we actually do with 5G, and also how does a crossing between 2 countries, including an MNO handover, actually affect driving performance in such a scenario. And then we have a different second type of control, which we call indirect control. Here, the operator defines waypoints that the vehicle has to follow, and then the operator can control how well the vehicle follows these waypoints. Here, the idea is that we actually wanted to try out a different concept where we combine the abilities of an automated vehicle with the human abilities. The automated vehicle following a trajectory, calculating the best path, and also monitoring the environment and reacting on the environment in real time, and the ability of a human operator to actually think about a situation, to define a good way, and to be able to anticipate upcoming problems and actually reacting to them in advance, for example, by setting different waypoints which are good for the current situation. And here, one might think that this could be easily done with 4G networks also. However, it also turned out that even for this indirect control scenarios, the bandwidth requirements are quite high. And also when you really want to have the operator into control, also the latency requirements are quite high. So again, even with the second concept, we were also really able to use the potential of 5G in the border area. Okay, let me get a little bit into what we call user stories in this project. User stories are real test cases for us. What we actually really implemented, what we trialed, and what we used in this project. And here we have 4 user stories that we worked on together with our partners, especially the TU Munich and also Volkswagen, and that we implemented together. Because one important aspect that we had here in the project was that we actually wanted to try out how can teleoperation actually work in a combination of a supplier as Bosch and an OEM, Volkswagen, also a research partner at TUM. So in the first user story that was implemented by Bosch, Volkswagen, and TUM together, we used the direct control concept, however low velocity, in an enclosed area. So first of all, why did we use an enclosed area? Well, in the end, it turned out that we wanted to be, that doing this on open roads still had some safety issues. So we wanted to be sure that this, that we are on the safe side and no one gets hurt during our trials. However, there is no conceptual problem with doing direct control on actual roads. It's really a safety concern for pre-development issues. And then we used low velocity. So that means we were able to drive up until 20 kilometers per hour because as it turned out that actually doing teleoperated driving at high velocities is quite complicated and will probably, especially on this direct control part, where actually a human really controls the vehicle, will probably not come into practice anywhere in the near future. And then we have a user story 2, where we basically did the same thing with indirect control. So again, this was implemented by Volkswagen, Bosch, and the TU Munich. And here we use the indirect control concept on an enclosed area, and again with low velocities for around about up to 20 kilometers per hour. Okay, then we also have the user story 3, which is monitoring only. Why did we do that? I mean, we really didn't implement any actual remote control here. However, we really wanted to see what happens if we go with our vehicle into the larger area, if we really go into the border areas of a 5G network. So where you still have some 5G coverage, but not really good, or where you also have a real chance of the connection breaking down, and also where you have larger roads that you drive, so you have MNO handovers. And for safety reasons, again, we couldn't do this with real actual control. So we couldn't put someone into control here and really steer the vehicle remotely. So we had a human driver in the vehicle, and then we especially considered the data streams. And especially this user story 3 really turned out to be very valuable for us because we learned so much about performance of 5G networks, or combined performance of 4G and 5G networks, and also the problems that we get when we get into areas where the 5G coverage is not so good anymore. And I think, to no surprise, I can say that we really learned that we need good 5G coverage for actual teleoperated driving. And then we have the user story 4, which was only implemented by the TU Munich together with Volkswagen. And here we have the indirect control concept again. However, what is called a slim uplink. So what does slim uplink mean? Well, for the other user stories, we actually transmitted real sensor data. So we transmitted camera data and we transmitted LiDAR data. But here for the slim uplink, the vehicle does some pre-processing and actually reduces the amount of data sent by doing an analysis and a fusion on the data received, and actually extracting relevant objects, extracting relevant places, and only transmitting those to the teleoperator. So even with a decreased quality of service, this kind of teleoperation could be achieved. That was also the reason why we used indirect control here, because with indirect control, it's possible to have the vehicle much more into control than this would be the case with direct control. Okay, and obviously, 5G Croco is about cross-country or cross-border control. So here, all these use cases were evaluated in European border areas. As said, on the German-French border, close to Saarbrücken. I don't know if anyone knows this place, but there's this rest stop called Goldene Brenn, where we did most of the tests. And then you have the area around Schengen, where we actually drove over the River Mosel and from Germany to Luxembourg and back to Germany. So we're able to show that teleoperated driving actually really works cross borders. Okay, and that's also from my side. Yeah, thank you very much so far.
Thank you, Tobias, for this very interesting talk. I think it's very interesting to see how you have a different perspective from 5G Croco on direct control than, for instance, 5G-Blueprint. So that's the nice thing of research projects. You can challenge each other to prove each other wrong, basically. So that's always good to have these very, very valuable insights from you to be brought to other projects. And I'm really interested to see where this domain will continue further. So thanks for sharing these insights. I've seen in the question and answer chat box that there are several questions from the audience, which is great. Only looking at the time, I would propose that we first have the presentation of Koen, because we only have 15 minutes left, and then we can see how much time we have left to answer questions live. Otherwise, I would like the panelists to use the Zoom platform to go at the bottom of the screen to the Q&A section, apologies, and to at least type the answers after the session is done, so that at least the participants get a response, but maybe then we can do a little bit better time management to make sure everyone can do their presentations, if that's okay for everyone. If so, I would like to give the floor now to Koen, but maybe first I'd like to announce Koen. Tobias, if you could stop sharing your screen.
Yes,
that would be great.
Let me figure out how to do this. But oh, there is a button. Sorry.
Yeah, no problem.
Okay.
Yes, great. So I can share my screen again. So the last panelist of this first session is Koen Bresser. He's representing 5G Mobix. Koen joined Ertico's innovation and deployment team in July 2020, and his expertise lies within 5G, connectivity, and automation. Before joining Ertico, Koen worked for Sweco as a senior advisor in mobility and ITS, at TNO as a business consultant for network information, responsible for the 5G portfolio, and at Technolution as a consultant and business developer. At Ertico, Koen is responsible for 5G Mobix, the largest 5G cross-border project in the Horizon 20 ICT 18 call. His work is extended with transportation projects involved ports, implementing solutions based on 5G. Koen holds a Master of Science in Electronics Engineering from the University of Twente in the Netherlands. Koen, I'm very pleased to have you here today to talk about 5G Mobix, so please, the floor is yours.
Thanks, Wim. If all goes well, you should hear me. So let's share the screen.
We can hear you, yeah.
It's a start, and you should be able to see the screen as well, right?
It's all working, yeah.
Perfect, then let's start. I held my up to the instructions of having a short presentation, so we will have some time for discussion if it does all goes to plan. So 5G Mobix is a sister project of Croco, so it's very nice to see that we're both in. We handle similar problems. The whole point of ICT 18 is to trial as much 5G in a cross-border situation as possible. Indeed, originally it was a 36-month project, but it has been extended to 45 months, so we're living a month longer than you, Tobias. We have over 60 partners, actually over 70 partners in the consortium, which makes it quite massive and an interesting task to retain overview. But it also has a lot of opportunities to do very much and very different and similar things. What we do is we carry out trials along cross-border corridors, and I'll dive into the details a little bit later. And the whole point is to assess that 5G can be used for CCAM in a cross-border context. For that's what we do, not only the technological part, but also the business part, because it's nice that you can pick something in technology, but if there would have been a business case for cross-border communication, we would not have suffered from coverage gaps of 2 minutes currently. So there's no business case currently, and that needs to be solved as well. So that's what we're looking into as well. And then you get into legal, regulatory, and security issues at the same time. So the trials that we perform, we have 2 cross-border corridors. One is between Spain and Portugal with 2 bridges, one being a very old bridge, very nice one, but it's a cage of Faraday, so your 5G coverage becomes an issue. The other one is an actual hard border, so that means between Greek and Turkey, you're crossing legal boundaries, which has its challenges on its own, if only for getting equipment across the border with correct papers. That's an interesting aspect there as well. What I did is circle the places where we do automated driving. Sorry, remote driving and teleoperation, because it's all about automated driving, of course. To facilitate that, we have a little less than 30 5G GNODBs use an NSA architecture, but also an SA architecture, because that became available. We apply about 20 level 4 automated vehicles, which is also very nice. And what we did is we have 5 use case categories. I'll dive into the remote driving verbally in a minute. It's basically advanced driving, vehicles platooning, extended sensor remote driving, vehicle quality of support. What we did to come to valid and comparable results is we defined 13 issues that are happening at border situations. So we mentioned name them cross-border issues. It's either application or network telecom issue. We have around 30 solutions for these issues. And these 30 solutions we trial in more than 170 test cases. So that means that we do a lot, and that will help us to define the best way to come to an architecture. What we do with remote driving, it's similar to Croco at some points. For example, we have actual remote driving. We do that in the Netherlands with some interesting results. It's done by TNO and KPN. And what they notice there is that there is it's preliminary results, by the way, so no guarantees, that there is a limitation on the speed that you can achieve. And that limitation is based on what the driver can consume. And that is based on the HMI. So the HMI setup is very relevant here. It's not per se the 5G aspects, it's more how you make your teleoperation center. And for us, that meant that the limit would be somewhere around 30 kilometers an hour. And if that's the case, we'll have an issue. So that needs to be solved. So I hope, Wim, your 5G-Blueprint project has a different solution for the teleoperation center, because that may very well influence the speed that you can achieve. We do the indirect control as well. So that's a remote teleoperation. We do it in Finland, for example. It's an automated car. It drives, and at a certain point, it can't figure out what to do anymore. It comes up with a solution, suggests the solution to the operator, and you can accept or come up with a different one. In Spain, we use an automated shuttle that drives over that cage of Faraday. And in case of emergencies, a teleoperator, an actual driver, can take over. And that's quite interesting how to do that with these kind of 5G coverage issues that you experience in the case of Faraday. In the Greek-Turkish corridor, we do it with trucks that approach the border. There's some kind of evaluation on risk if a truck needs to be searched, verified. So the customs site can demand a truck to go to a different location. And that's a combination of giving a path and a combination of actual remote driving in specific cases. So how do we do that? And in France, by the way, we do a similar remote driving solution as in Spain, Portugal. So how do we do it? This picture is wrong, but it can be used to explain the concept. Basically, you have two slices that you need. You need a low latency slice, and a reliability slice, and you need a massive broadband slice. The latency, of course, is for your control and your control signals, and the high bandwidth is for the feedback. What we also noticed is that these channels may not have the same aspects and characteristics, so that means that the control you send, the timing is actually quite relevant. So if we go to the next, this is a slide overview of where we do what. So it's SA networks, multi-SIM functionality in Finland, service discovery. You see SA quite a lot, multi-SIM modems, edge computing we use, of course, NSA networks with roaming. So this is basically the highlights of the 5G things we do. We do a millimeter wave, national roaming we try. As mentioned earlier, the consortium is huge. These are the partners that make up for a very interesting project and hopefully very useful evaluation results. Thank you. That's it for me, Wim.
Thank you, Koen. Thank you for this. Also, again, very, very interesting talk, and always great to see these kinds of first lessons learned, like indeed the limitations on the speed of the direct control, 30 kilometers per hour, that otherwise, HMI and so on, is getting hard. So one thing that caught my attention in the previous 3 talks is there are different angles of looking at teleoperation. They all have their own big challenges. It's something I learned here. Right? The direct control is mentioned. Yeah, you can't go too fast. The network you are so hard on the network that it becomes challenging to really deploy this at scale later on. The other way around, the indirect control is less challenging on the network, but you need better automation in the vehicle as a prerequisite to be able to deploy. So there's no perfect solution, and Tobias started with it. It's always like a mixture of some form of automation, some form of teleoperation. When we would looking at actual deployment, using it in the domain of transport and logistics, because that's the sub-theme of today, do you see a sweet spot in terms of environments or applications where it's feasible within a relatively acceptable time frame to have both network and automation at an acceptable level, so that you could really start deploying and using it in a day-to-day life? Where do you see that sweet spot of this all coming together for the first time?
Well, if no one starts, I'll make a start here.
Please do.
I mean, first thing is that you have to consider what is actually the environment of a vehicle like, and which environments are quite friendly to teleoperation and which are quite adverse. So for example, the city center of Stuttgart, which is close by here, is quite adverse to teleoperated driving. And instead we have to look at which use cases could actually be viable for teleoperated driving. And there I would say that on site, on a logistics center site, or on a, I don't know, mining site, whatever you may imagine here, where you have a limited area where you do not have, you know, the general public, but people who can be trained to move there around teleoperated vehicles, that these areas will be the first that we will see teleoperation. And also, I think it will at least be quite close to full human operation of these vehicles. Maybe we see some sort of less indirect control than what we saw here in 5G Croco, and not the full direct control. But this part is probably easier to implement, because, you know, getting automation and people together is also quite a hard challenge, and it will probably be easier, at least in the first place, to make sure that in a limited area we have quite good 5G or 60 gigahertz Wi-Fi, whatever you may imagine. But I personally probably go for 5G coverage, so that you can actually really have a good connection to the vehicles, low latency, and where you have a environment that you can at least to some extent control and optimize for teleoperation.
Yeah.
Public roads are going to be a later thing, and there we are probably going to see more automation and less humans.
Yeah, so your advice would indeed be to start in simpler environments, so to say, with the technology deployment, and build it up from there, which is indeed, yeah, both for the teleoperation as also for the automation elements that need to come together, always makes sense, I think so. But indeed, thinking about your ODD, basically, when looking at actual deployments, is an important way to start and look really at an evolutionary model, and not wait until it's ready to be deployed directly in the more complex environments.
Yeah, I mean, what we learned in the automotive industry is, anyway, you have to start somewhere, and from there you go.
Yeah, yeah. Okay, thank you, Tobias. I see a lot of cameras popping up on the panel. I don't know if someone else wants to continue on something Tobias has said, or on the question I asked.
I would like to add to Tobias' perspective something that we are early realizing in 5G Blueprint, and certainly it's the uplink capability of the 5G network. So where is going to be easier or faster to start implementing teleoperation in the transport and logistics sector? I would say where we have a really good 5G network coverage, and then we shift to the deployment issues, to the deployment challenges. And I will add something else on top of this: regulation. Who's liable of what? That is something that it's not technical. I know we are talking about technical matters here, but I think regulation has to will spare the development, or will delay the development, because who's responsible of what in teleoperation? It's the network, and we know that we really need high uplinks, in particular high uplinks, to transfer all this information from the sensors. What happens if that information arrives late? Where was the delay? Who's responsible of the failure? I think that's a different aspect than technical, that puts pressure on the complete development at the sweet spot on deploying teleoperation. Thank you.
That really shows the value of performing these projects, because regulation is always late. They will not know what to regulate unless the technology and the knowledge is there. So that we perform these projects is highly relevant. The only way to do that is actually by trialing it. And what we notice at least is, if you want to trial on street in real life environments, this regulation is blocking you, because there's a general rule that you're not allowed to do this on highways, for example. And that means that it's a catch-22. However, by trialing in controlled environments, you do get this knowledge on how to achieve this. And to follow up on Tobias's view there, I totally agreed on that, because there are several timelines that converge. You have a timeline of automated driving, which is kind of independent of the timeline of remote driving. However, the more automated driving becomes a reality, the less relevance there is for teleoperation. There might be for teleoperation,
sorry
to give it a name.
No, actually teleoperation gets more important the more automation we have.
Yeah, unless if automation is incomplete.
Yes, and it will be for the foreseeable future.
Yes, definitely. Exactly, but that means that there's still timelines that are potentially conflicting, or at least they are related in some way. So to get automated driving with all the problems on street, teleoperation is a very good solution. And then you get into how to achieve that. Then the 5G timeline comes into play. So when do all the governments, when do all the operators need to deploy full 5G everywhere? And those three timelines are constantly shifting, so that makes it a moving target. That is a difficulty, but it's a challenge, and challenges are there to solve.
Okay, thank you all for these insights. So I think if we can summarize it, teleoperation from a network perspective is the love child of URLCC and EMBB, both high bandwidth and low latency critical applications. So double challenge to the network, and its best friends is automation, because they really seem to be going together and they all have to converge to become one integrated solution. So I think definitely still have the appropriate challenges for us. I think there were some other questions in the question and answer section. Maybe the one last thing I want to take for that, and the rest we can just, I would invite the panelists to just type the answers using the Zoom interface. But I think several questions coming from the audience are indeed, just to make it more concrete, these latency and bandwidth requirements for one vehicle, teleoperated. Could you give our audience an idea of what we are talking about? How big are these requirements? How hard is it challenging the network?
Depends on your speed, right? Every millisecond is a couple of meters, so the higher the speed you use, the lower the latency should be. And there's no good solution. The lower it is, the better it is. So the higher it is, the lower your speed will be. You can calculate it.
Okay, but any ballpark figures? I think 20, 30 megabits per second uplink, is that something you can expect of a single vehicle, given that you have
in some
cameras?
trials we get to the 10 milliseconds, and that is okay-ish, but you will not get into the 80 kilometers an hour. So 10 milliseconds is quite a different, and then you get your reaction time, and then you get your control delay. So if you look at a round trip delay, that full round trip from sensing or seeing your sensing from the actual event to getting it on video, towards the remote driving center, towards the reaction time of the driver, towards the input of the control system, towards the execution of the control system, that all adds up to meters. And every meter is potentially a safety issue given the speed that you have.
And also you have to consider the glass-to-glass latency. I mean, even if you put the 5G latency to 0 milliseconds, obviously not possible, but even if you did it, there are a lot of other latencies. I mean, you have to get somewhere from the base station to the control center. I mean, where is a control center? It's remote control, it's teleoperated, so it's tele by definition, and you have to get there. And I mean, you can go there via the internet, which really is kind of problematic because it's a best effort network. Then you have the time of the camera to actually capture a picture, which takes ages. And so
Compression
overall, you have
algorithms.
lots of latency problems, and 5G is only one.
Exactly.
Okay, so don't buy a cheap display when you're building an operator station. That's a low-hanging fruit. No,
No
okay.
way.
Yeah,
Oh, yeah.
yeah.
An integrated solution, actually, and part of the integrated solution is where will you place your teleoperation centers, and where you will place your teleoperation centers is dependent on again speed and what you want to do with it. But you can't do it from one center in Europe. It's plainly impossible.
I agree with that, and I think this is a problem that we need to solve from a holistic perspective, and that's where the vertical the vertical expertise and knowledge, it's really needed in order to deliver the right network. So this is not about delivering only zero milliseconds 5G latency. It's about understanding their ecosystem and designing a network for this ecosystem, a network where we have, let's say, edge computing, and we have 3 different control centers. The closer, the better, because I think we are going to end up having a design like that. The closer, the better. The closer control, the better. Otherwise, it's not feasible. I think we'll see in 5G Blueprint. We'll see how it goes, and that's the purpose of this project, to test and to suggest what worked better, same as, of course, as your other projects.
I see a remark, by the way, from Maxime, which is should be regarded very rightly. Vehicles themselves have high automation capabilities, and they should be. Eventually, the car manufacturer supplies a safe vehicle. So that means that if you do not have teleoperation, that car will have some kind of safety somewhere. So teleoperation will only add upon additional features for that safety. So it's, in my view, a good remark from Maxime.
Yeah, thank you for that. I also see another remark from Amit, which is also true, that we are late for our next session. So we have a lot of additional experts all burning ready to start sharing their knowledge about this very interesting domain. So with this, I would like to close the first session. I really want to thank Tobias, Koen, and Johan for participating and for sharing your insights and also preparing the presentations.